Okay, so for each of these warm-up problems, I wanted you to sketch what the graph might look like. Rough sketch, doesn't have to be, just there's a key thing that you're going to hopefully notice about both graphs that will then hopefully connect to your results when you try to solve it algebraically, right? So if we're thinking about this equation, y equals 3x squared plus 48, you could think about it, hey, it's standard form, or you could think to yourself, oh, I kind of remember from parent functions, the plus 48 makes it go up, and then the 3 makes it stretch, right? So the only thing that's going to happen here is this goes up a lot, right? And then it stretches. So it would kind of look like that, right? There's really not much I was hoping for you to get from these sketches except for one thing, which we'll talk about after we do the other one. Okay. So this other one, well, this is in vertex form. So what's the vertex here? Yeah, 4, negative 32. So you just kind of estimate over a little bit, down a lot. And then the negative 2 out front tells you it's going to stretch and flip down, right? So it's going to kind of look like this. Okay? What do these two things have in common? Well, they're tiny and they're really far away from what? The x-axis. Do they cross the x-axis? No, so they don't have what? X-intercepts. So we have no x-intercepts in both situations. No x-intercepts. Okay? All right, let's keep that in the back of our minds, because now we're going to take the same equations and solve them algebraically, meaning the way we learned last week. This is missing its bx term. That is vertex form. If you get either of those situations, this is the strategy. So if you miss that class, I'll talk through the strategy as I do it, okay? We will get weirder answers than we got last class, but it's the same process. We'll focus on this one first. All right, so with any of these problems, whether you're in standard form, intercept form, vertex form, whatever, the first step is you set y equal to what? 0, right? So 0 equals 3x squared plus 48. And then I notice, oh, I'm missing my bx term. When I'm missing my bx term, I can solve by square rooting, right? I don't have to do factoring and then pull it apart or anything like that. I solve by square rooting. However, to solve by square rooting, the very first step is to isolate the square. Isolate, what does isolate mean? Get it by itself. So what do I mean by the square? Well, what's being squared here? Just the x. If it was in parentheses, it would be 3x. Just the x is being squared, so I need to isolate that, right? And I know we're not doing this problem yet, but let's talk about this one. What's being squared here? X minus 4. So that's the square. That's what I need to get by itself, right? Remember with equations, when you're trying to get something by itself, you're trying to isolate it, you get rid of everything else. You move everything else to the other side, right? So for instance, in Algebra 1, I would say to help students, like when we're doing simple equations, draw that line down the middle. It still works, right? It still works. Helps you see what side you're on, right? Because if I'm trying to isolate this x squared, right, this part right here, oops, what do I need? It makes it very clear the things I need to move over. There's two things. What are they that need to go to the other side? I need to move the 48 and I need to move the 3. Which one do we usually do first? Yeah, add or subtract first. So I'm going to minus 48 and minus 48. My result is negative 48 equals 3x squared. Still don't have the square isolated. There's still a 3 over there. What do I do to get rid of a 3 times? Divide, right? So divide by 3, and I get negative 16 equals x squared. Now, what's the step now that I've isolated? Yeah, I have to square root it, right? I have x squared. I want to know what x is. I'm trying to find a solution, an x, right? Not an x squared. So I need to square root. So I square root, and I square root, right? Now, what do I get x on this side, And then what's the square root of negative 16? Okay, let's try 4. 4 times 4 is? That's not what a square root is. A square root is when you get the same number multiplied by itself to get a number. All right, 4 times 4 is 16. Negative 4 times negative 4 is also positive 16. Right. If I put square root of negative 16 into my calculator, it would say error, right? That's the calculator trying to tell me that doesn't exist. That's not real, right? There is no answer here, right? Now, why do you think that happened? We didn't do anything wrong in our solving. Why do you think we didn't get an answer? There's no x-intercepts, meaning there's no solutions. There's no solutions, okay? Now, think about why we set y equal to 0. Because 0 is when you have an x-intercept. If you look at any x-intercept, it is x comma 0. It's some number x and then 0 for y. We were trying to find that. So we set 0 to y. But this thing never had any x-intercepts in the first place. So of course we didn't get anything real. We didn't get any solution because there is no solution. So if you get a square root of a negative, you know the situation. You know, actually, if I graph this, there wouldn't be any x-intercepts. And if you graph it and get no x-intercepts, you know that if you solved it, you'd get a square root of a negative, right? It wouldn't work. Think about what a solution is. We can look at this at a couple different points. Think about this point of the problem. We had negative 16 equals x squared. This is before I even square rooted it. Right away at that point, if you're thinking about what you're doing, you should be like, wait a minute. What happens when you square a number? If it's negative or positive and you square it, what do you get? A positive number. So you're trying to tell me that there's a number that I square and I get negative 16? No, I already know this is not going to work, right? Think about the original problem. We just said when you square a number, it's always what? Okay, so some positive number times 3 plus 48 is going to be equal to 0? That's impossible, right? That would never happen. So it makes sense that we didn't get a real solution here because this thing was flawed from the get-go, right? It was never going to work. But that's okay. Sometimes we get problems like that and we have to know what to do with them, right? So today is what we talk about. We talk about what we do when that happens, right? And guess what? Spoiler alert. What do you think is going to happen over here? Very similar thing, right? But we're going to go through it because this will be good practice for using square root to do vertex form, which is a little trickier, right? So again, we set it equal to 0. Negative 2 times x minus 4 squared minus 32. Now, what are we trying to get by itself? We're not trying to change its form. We don't have to. We want x minus 4 squared to stay, and we want everything else to move to the other side. So just like if this was x squared, I'm going to do the same movements, right? I know it's x minus 4 squared, but still, I think of it as this thing I'm trying to get by itself. So what should I do first? Add 32, right? Just like I did on the other side, I moved the number to the other side. And I get 32 equals negative 2 times x minus 4 squared. Okay, so I'm trying to get this by itself. What's happening to it? It's being multiplied by negative 2. So how do I get rid of multiplication of negative 2? I divide by negative. And yeah, it's weird because I got to divide this whole thing by negative 2, but that's okay. It works. And I get, again, I got negative 16. Should have came up with a different number because it's not always going to be negative 16. That's a coincidence. And then I got x minus 4 squared. Okay. So if you have something squared and you don't want it to be squared, what do? You square root it. Just because it's not x doesn't mean we can't square root it. We can square root anything that's being squared, and we get the piece in the middle, right? So I square root, and I square root, and I get the square root of negative 16 equals x minus 4. Now, I could add 4 to both sides here if I want to, but I already know what. What I have already is impossible. I can't square root a negative, so there's no, and I'm going to use a word here, real solution. There's no real solution because Real numbers are one type of number. I know it feels like a number is a number, but there's a lot of different types of numbers. There's complex numbers, there's imaginary numbers, right? We just most of the time work with real numbers. Today we're going to talk about imaginary numbers, and it might be a little confusing, but I will try to explain it as thoroughly as I can. Yeah?
How many different kinds of numbers are there?
I mean, I don't know off the top of my head, but even integers versus whole numbers, those are two different types of numbers, right? There's a bunch of different sets of numbers that you could talk about. Yeah. I mean, there's math beyond what I understand, so I'm sure there are plenty of types of numbers I don't even know about, you know? It just keeps getting more and more crazy as you get better or higher and higher in math. And what we're going to do today is actually really valuable for higher level math. So if you see yourself as a person who's going to be going up and up in math, important lesson for the foundation of that, okay? All right, so no solution, no real solution is how we're going to say it. Now, here's the problem. Let's say I got to this point, and I said, well, x equals the square root of negative 16. And let's say I was building a spaceship, and this was part of my work to work out the spaceship, or I was building a cell phone tower, or something important, and I can't go any further, right? I'm grinded to a halt here. What if there was a way to keep going? A way that we could continue the process? So, in order to do that, we need to pretend a little bit. And that's where imaginary numbers come in. So we want to keep going. So this is how to keep going. Okay? So how are we going to keep going here? Well, this is where imaginary numbers come into play. So what we're going to do is you have a question?
Yeah. Can't you remove the negative or something and put it out there?
Kind of. Yeah. That's kind of what we're going to do. So we're going to pretend that there's one number that you can square root and it's negative. Okay? So we will pretend that you can square root the number negative 1. We're just going to pretend that you can square root negative 1, okay? Because just doing that will open a lot of doors for us, okay? So what are we saying? What we're essentially saying is we know in reality you can't take a number times itself and get a negative, right? But we're going to pretend. We're going to say, hey, what if there was a number times a number where you could get negative 1? Just a number times itself where you could get negative 1. But here's the thing. We don't want to have to write number sign every time. So somebody at some point said, let's choose a letter and we'll call it I. So I times I equals negative 1. And every time we play in this imaginary zone, we'll just use that letter to represent what we're talking about. All right, so I times I is negative 1. We know that's impossible. You can't actually multiply a number by itself, but we're imagining, right? And if I times I is negative 1, well then I squared is negative 1, right? I times I is I squared, right? And the other thing we know is that if I squared equals negative 1, well, think about if this was a problem that I asked you to solve for I, what would you do? Square root. So if I square root this, and I found my I is the square root of negative 1. Okay? So we're imagining that there's this number that you can multiply and get a negative, multiply by itself. There's two big takeaways here. Two things that you kind of want to memorize. I squared is negative 1, and I is the square root of negative 1. Okay? Those are two pieces that we're going to play with. Okay? Because those two things will allow us to keep going when we get to this imaginary zone, and sometimes get back to the real zone. And that's why it's valuable. So the big question every year is like, well, why, if it's imaginary, why keep going? So everybody here likes their Wi-Fi, right? Everybody here likes their cell phones, right? to measure the waves of light, to measure the waves of the ocean. They use imaginary numbers. That's the only way you can do it, right? Somebody was doing the work, they got to the imaginary zone, they worked through the imaginary zone, they got back to the real zone, and they got a real answer out of it, right? So it allows you to continue doing math problems that would grind to a halt if we didn't use this practice, okay? So that's why it's important to know this, right? That's why it's important to learn this. And as you go up in math, you will see more and more examples of getting from here back to a real place, okay? All right, so that's what they are. That's why we use them. Now, today all we're going to do is practice using them a little bit, and not even in a quadratic situation. That'll come up, right? But we want to get used to using I. So that's all we're going to do today is get used to using I and learn about the rules. Here's an example of how to use I at its very basic form. Okay, remember when we were talking about simplifying square roots, and I had the square root of 32, and I said, well, it's not a perfect square, we can't square root 32, but we can work with it a little bit. We can keep going a little bit if we think about what? Yeah, the numbers inside of 32 and pull it apart, right? What's inside of 32? 16 and 2, and then I can do more work now because I've got it to a better place. Square root of 16 is
4.
plus or minus 4, but sure. And I get plus or minus 4 square root of 2. I was able to keep going by pulling it apart. Same concept applies here. The square root of negative 9 I cannot do. But if I rewrote this as 2 square roots multiplied by each other, maybe I could work with it. What do you think I should do? How do you pull apart 9? Thinking about what we just talked about in the last page. Well, 3 and 3 won't help us. But good thought. What goes into 9 besides 3 and 3? 9 and 1. But I have negative 9, so 9 and good idea. Now, what have I accomplished? Well, square root of 9, can I do that? Yeah. What's that? Plus or minus 3. And then the square root of negative 1 we just defined. What did we say the square root of negative 1 is? I. And now I have an answer that I can keep going with. I can work with this, right? And you'll see how to work with it, but you work with it just like you work with X or Y or whatever. You have a number you can work with. Couldn't do anything with this, can do stuff with this.
So, if I understand what you're saying, if we're going to move on to, let's say question 2, the second question the answer would be square root of 16 times the square root of negative 1, and then the square root of 16 is 4, so it would be plus or minus 4i.
Exactly. Yep. And you can do things with that you couldn't have done with that. Yeah?
I is always square root of negative 1.
It's always the square root of negative 1. Yep. That's what it represents. Everyone in math accepts that. Okay? Now, that's if I already had a negative perfect square. But even if I didn't have a negative perfect square, like in number 3, right? It's not a perfect square. But let's start with what we just did. What's the first thing I could do to pull this apart? Well, I'm going to do it I'll do that in a second. Let's just do this first. So square root of 8 times the square root of negative 1. First thing we do is get that negative out of there so we can work with the 8. And then you're right, the 8 we can break down further into?
Negative.
Well, it's a positive 8 now. So now it would be square root of 4 times square root of 2 times the square root of negative 1. So square root of 4 is plus or minus 2, square root of 2, and then what's square root of negative 1? I. Now, what is this saying? It's just saying this times this times this, right? So what I would suggest is you pull the I out front, flip these two. Because a lot of times students write this and it looks like plus or minus 2, and then they just make a big old square root, and then they write 2i, and it looks like they're square rooting the I too. You don't want it to look like that. A way to protect against that is just put the I in the front. Like This isn't wrong, but this is clearer, okay? If you move the I out front. Plus or minus 2I square root of 2, okay?
So we go from that to that.
So this becomes that.
Yeah, but what I mean, like when we're writing it for like the answer,
Mhm.
it goes from that
From this to this?
to that.
Yeah. Yeah, or you could have just known that your I was going to go out front, so you could have arranged it differently in the middle step, right? All right, now, square root of negative 17.
Well,
We can't, is that a perfect square? Are there any perfect squares inside of it? No. Can't break down 17, right? But I can say square root of 17 times the square root of negative 1. Square root of negative 1 becomes I. And it becomes plus or minus I square root of 17. Now, the reason I chose this example is 2 reasons. That we can always at least pull out the I, 1, and 2, a lot of students think, well, I didn't actually square root anything, so I don't need the plus or minus. Here's the thing. You do want to do the plus or minus, because if you had like x squared plus 17 equals 0, this is a scenario where you might get that, right? Well, this is a quadratic equation, right? How many solutions do they usually have?
2.
Either 1, 2 real, or 2 imaginary. Those are the only possibilities, right? If we don't do plus or minus, we won't account for one of the imaginary solutions, okay? If I would minus 17, I would get x squared equals negative 17. I would square root, and I would have to say x equals, and that's where I got to this point, right?
Yeah.
Plus or minus I square root of 17. Because I need to account for both imaginary solutions, okay? Plus or minus. And that's going to be one of the biggest mistakes people make is they forget that plus or minus. So just be careful. All right, so that's how you kind of change radicals with I. But you also are going to need to add and subtract and multiply when I is involved. So this is kind of stuff we need to know how to do for the next class where we start going back into quadratic equations a lot more, okay? So we're going to add and subtract, and then we're going to multiply, and then we'll be done. Okay, so it says adding and subtracting with I, and I put it right here. Treat it like a variable, just like if it was x. That's why we changed the weird square root of negative to a letter, so we could keep working, right? If you have 7 plus 5i minus 3i, just think of it as, what if I had 7 plus 5x minus 3x? What would I do? What could I bring together?
It would be 2I.
Yeah, 5x minus 3x is 2x, so this will be 7 plus 2i.
And would you put it as like 2I plus 7? 'Cause-
No, it would be the opposite. A plus bi is the complex number form.
okay.
Yeah, so there's something called complex numbers that you would write you write them in this form, the number plus the number times I. So this is the proper way. I wouldn't take off if you wrote it 2i plus 7, but if you want to know the form, it's that. Okay? Good question. Okay, let's keep going. Here, I have a binomial plus a binomial. I'm adding, I'm not multiplying, right? And because I'm adding, are these values going to change?
No.
No. No, because think of it, it's like a plus 1 out here. Plus 1, well, that multiplies through and nothing changes. So if you're adding, just drop your parentheses. This is just like if we had x in here, right? And this is from like our first unit, right? When we were just combining like terms, right? Think of it that way. Now I drop my parentheses, I look for my like terms. I got 4 and 8, 2i, negative 7i. Just bring together your like terms. What's 4 plus 8? 12. What's 2i minus 7i? Minus 5i. And that's as much as you can do. Do not say, oh, that's 7i. It's the same reason you wouldn't say 12 minus 5x is 7x. You can't combine unlike terms, right? This is two things that can come together. When things can't go together, you just write them next to each other, right? That's all we can do. Okay, now this example, number 3, very similar, except I'm subtracting, right? So if you're subtracting, What does that mean about the second parentheses?
Multiply it all by -1.
The signs change. Now, if you forget that, think about as if there was a 1 out here. -1 is being distributed through here. -1 times this, -1 times that, right? So those signs change. So you can just bring down the first parentheses, right? And then the second one would be -8 minus 3i, right? Now I combine my like terms, now that I've set it up in a way that looks clearer, right? So I got 6 and -8, 5i, -3i. 6 minus 8 is -2. And then 5i minus 3i is plus 2i. And there is my solution there, or I should say my simplified expression. All right? Now, try the last one, and then we'll do it together. Okay? So not last. Yeah, that's the last one in the section. Do number 4, and then we'll try it together. So when you were not here, we talked about when you're adding and subtracting or multiplying, dividing with I, pretend it's x. If this was x, you know what to do, right? It would be 6 plus 5x minus 8 plus 3x, and you would just distribute the negative.
Oh, okay, yeah.
And then combine your like terms. Yeah.
The I by itself on the bottom one,
Mm-hmm.
is using it as, like, I'm gonna put it towards the 2 and the 5?
Well, if you had an x by itself, what would you imagine was when there's none, there's 1. So it's like 1i, and just treat it that way. Yeah. If we're multiplying, but that'll be in the next section. But that's a good question. Yeah, you would square I if you're multiplying. Yeah.
I think I need. Okay.
All right. So I got a subtraction on the outside. So what am I going to do?
Flip the sign.
Flip the signs in here, distribute the negative. So I get, well, actually, is there anything I can do first? Yeah, like 2i plus 5i, I can actually make that, what? 7i, right? So I'm going to say 7i, and then I will distribute. So -4, and then plus I. Just like if you had x, it would be plus x, right? Or 1i if it's more comfortable for you to think about it as that. So if I have like terms are 7i and I, or 1i, and then this one's by itself. So what's my answer?
-4 plus 8.
-4 plus 8i.
It's -4 plus 8i. And that's just because we write the number first and then the I second. Okay? If you wrote 8i minus 4, I probably wouldn't take off, but that is the right way to write it. Okay? All right. That's adding. So multiplying, again, you're going to treat it like it's x. You would square it, right, if it's time to square it. But there's an extra piece that you need to keep in mind that's going to make it a little confusing. I'll be honest with you. All right. Before we talk about multiplying with I, I'm going to, yeah, question?
About number 4.
Yeah.
Why did we add I instead of subtract I?
Because it was minus, which makes it a plus. Yeah. Okay, so before we multiply with I, I'm going to remind you of something from the front of this page. Remember, we said I is the square root of -1. But we also said there's another key thing to remember. I squared is what?
The square root of -1.
No, it's the square root of -1 squared, which is just -1. I squared is -1. Okay? Remember, there's two things. I is the square root of -1. I squared is -1. So that's going to come into play. Not in this first example, though. In this first example, I have 7 times 6i. If I had 7 times 6x, what would I have? 42x. So what do I have here? 42i, right? And that's it. That's all you have to do there. Now, where it gets a little more confusing is when you have something like this. 2i times 3i. So I got 2 times 3, which is, and then I got I times I. That's I squared. Great. But in math, if we can keep going, we keep going. And we know that I squared actually has a value. What is it? -1. So really, this is 6 times -1, which is -6. And this is actually a great example of why you use imaginary numbers, because you can get back to a real number throughout your process, right? Sometimes you end up with imaginary in the middle of the problem, but by the end of the problem, you get back to the real world. And that's valuable, okay? All right, so that's going to happen if you get if you get I squared. You've got to replace it with -1 and then continue to simplify. All right, let's look at number 3. All right, if I have something on the outside of parentheses, what do? Distribute, right? So I'm going to write out the distribution, and if I is confusing, I suggest you do this too. And what I mean by that is I'm going to actually write out 4i times -6 plus 4i times I, right? That's what we do when we distribute, right? We multiply through. This gets multiplied by both things. And then I look at them one at a time, rather than try to do this in my head, right? So 4i times -6, that's what?
Negative 32i.
24, right? -24i, right? And then 4i times I, 4i squared. But we know that that's actually -24i plus 4 times what? -1. Whoops. And what is 4 times -1? -4. So this is actually -24i minus 4. Plus -4 would be -4, right? And then one more step, if I want to write this properly. -4 minus, that was weird, minus 24i, and there we go. Okay? All right, a couple more. Yeah. All right, next one. If I have -2i squared, what's an easier way to, well, a more clear way to write what is really happening there? -2i times -2i, right? So, -2i times -2i. Now it just becomes almost like number, I don't know, 2, right? Because you do the multiply, just if you had -2x times -2x, you would multiply the numbers, you'd multiply the letters, and then you'd get your result. So what's -2 times -2? 4. And what's I times I? I squared, which is -1, right? So 4 times -1, so this is -4. Okay? Right? -4. Yes?
We've gone through adding and subtracting and multiplying with I. Will we ever be dividing with I?
In math, sure. But it's not going to come up in the quadratics unit. Yes, question?
Can you re-explain everything from 4i squared?
Okay, so we know, this is a good question. So I know that I is what? What do we say I is? It's the square root of -1, right? Well, I squared then is the square root of -1 squared.
Which is -1.
When you have a square root that's squared, those cancel each other, and that means I squared is actually just -1. It's a real number. So if I get I squared somewhere, well, I'm trying to get out of the imaginary zone, so I plug in the real number that can go in its place. And I squared is -1, so 4 times -1 is -4. Yeah?
How did they decide what that number was?
They had a big meeting with all the math people, and they said, we're going with it. I don't know. Usually in math, someone comes up with a theory, and other people like it, and then it just becomes an accepted practice. I couldn't tell you who invented this. I'm not a math historian. I missed that class. All right, last example, and this one gets a little convoluted, I would say. But if you take it one step at a time, it's not that bad. So just follow along. Okay, here I have 2 binomials, meaning 2 terms and 2 terms. We know when we're multiplying 2 and 2, we have to do a couple different things. So we have to choose from a couple different options. What's one thing we could do when we multiply binomials?
Foil.
FOIL. And that's what I'm going to do now. You could also do the box method. I'm going to show you FOIL. Because FOIL, in this case, I think will be less confusing. Now, I'm going to do it. You know how when you FOIL, you kind of just write your result? You don't actually write out the FOIL? I'm going to write out the FOIL. And if you find this stuff to be confusing, I suggest you write out the FOIL too. And this is what I mean by that. FOIL is first. So I'm going to write 8 times 2 plus. Right? I'm going to write each one. Outer. Okay, that's 8 times negative 3i. Right? Plus. Inner. 5i times 2 plus last 5i times negative 3i. Now the reason I do this is you can just look at them one at a time and start simplifying each one, and then each step do a little bit more. You don't have to think about the whole thing at once, right? If you get really good at these and you want to not have to do this part, that's great. But this is what I suggest. Because each one of these can now be simplified a little further. Right? What is 8 times 2? 16. Plus, what is 8 times negative 3i? Negative 24i. Plus, what is 5i times 2? 10i. Plus, and what is 5i times negative 3i? Negative 15, and then I squared, okay? Now, I don't actually need these pluses when I have a minus, so I'm going to rewrite this a little bit. 16 minus 24i plus 10i minus 15i squared, okay? Now, is there anything we can do to keep going here? There's a couple things, right? Combine like, what are my like terms here? Right? Just like if I had x and x, negative 24i plus 10i, that comes together and becomes 16 minus 14i minus 15, and I had I squared. That's negative 1. Okay? Let's keep going. Anything I can do here? What negative 15 times negative 1 is what? Positive. So I have 16 minus 4i plus 15. Anything else I can do? Yeah, I got 16 and 15. You can add those together. What is that? 31 minus 14i. And there's nothing else I can do here. And that is how you do it, right? So I know it's a lot, but if you set it up step by step, just do piece at a time. Question?
If I did box, would that give me, instead of writing it out like how you did, if I do box, which one will I get? Like the middle row?
Yeah, so box would give you this, 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 and this in your box.
Okay.
And then you just need to think about how to combine those like terms. Okay? Other questions? All right, homework.